Hi, welcome to ExamPadi's physics class. Our topic today is rectilinear acceleration part 1. In this lesson we will 1. Define acceleration and differentiate it from velocity and speed. 2. Calculate acceleration and interpret the results. 3. Analyze velocity time graph and interpret the slope, horizontal line, positive and negative slope, the curvature and area under the curve. 4. Understand the applications of acceleration in various fields such as physics, engineering, and sports. What does acceleration mean? Compared to displacement and velocity, acceleration is like the angry fire-breathing dragon of motion variables. It can be violent. Some people are scared of it, and if it's big, it forces you to take notice. That feeling you get when you're sitting in a plane during takeoff or slamming on the brakes in a car are all situations where you are accelerating. Acceleration is the name we give to any process where velocity changes. Since velocity is a speed and a direction, there are only two ways for you to accelerate: change your speed, or change your direction, or change both. This is a pictorial depiction of acceleration. If you're not changing your speed or you're not changing your direction, then you simply cannot be accelerating, no matter how fast you're going. So, a jet moving with a constant velocity at 800 miles per hour along a straight line has zero acceleration, even though the jet is moving really fast, since the velocity isn't changing. When the jet lands and quickly comes to a stop, it will have acceleration since it's slowing down. Or you can think about it this way. In a car, you could accelerate by hitting the brakes, which would cause a change in speed. But you could also use the steering wheel to turn, which would change your direction of motion. Any of these will be considered an acceleration since they change velocity. So, we can define acceleration as a change in object's velocity, which can be an increase or decrease in speed or change in direction of motion. Examples of acceleration include an apple falling from a tree, the moon orbiting around the earth, or a car coming to a stop at a traffic light. Acceleration can be observed in various applications such as transportation, human and animal movement, and the movement of objects and equipment. The greater the acceleration, the greater the change in velocity over a given time. Mathematically, acceleration is defined as the rate of change of velocity with respect to time and is the second derivative of displacement. It can be calculated by differentiating the position with respect to time twice, or differentiating the velocity with respect to time once. The SI unit for acceleration is meters per second squared. What are the types of acceleration? Number 1, average acceleration. The average acceleration over a period of time is defined as the total change in velocity in the given interval divided by the total time taken for the change. For a given interval of time, it is denoted as A. If AV is the average acceleration and change in V equals velocity 2 minus velocity 1, the average velocity over the time interval change in T, then mathematically AV equals change in V over change in T equals V2 minus V1 over T2 minus T1. 2. Instantaneous acceleration. Instantaneous acceleration is defined as the ratio of change in velocity during a given time interval such that the time interval goes to 0. 3. Uniform and non-uniform acceleration. Let's talk about uniform acceleration. An object is said to move in uniform acceleration if an equal amount of velocity increases in equal intervals of time. Velocity time graph for the uniform acceleration is a straight line. An example of uniform acceleration is a free fall object possesses uniform acceleration. Non-uniform acceleration. An object is said to be with non-uniform acceleration if the velocity of the object changes by unequal intervals of unequal amounts in equal intervals of time. Velocity time graph of non-uniform acceleration is a curved line. An example is all circular motion types where speed is constant and direction changes at every point. Now, let's discuss some applications of acceleration. Acceleration has a wide range of applications in various fields, including physics, engineering, transportation, sports, and more. Here are some examples. 1. Physics. Acceleration is a fundamental concept in physics and plays a key role in the study of motion, force, and energy. It is used to describe the behavior of objects moving in a straight line or in a circular motion. 2. Engineering. Acceleration is used in the design and testing of engines, vehicles, and aircraft. Engineers use acceleration data to optimize engine performance, improve fuel efficiency, and ensure the safety and reliability of transportation systems. 3. Transportation. Acceleration is an important factor in transportation as it affects the speed and efficiency of vehicles. For example, acceleration is used to calculate the time it takes for a vehicle to reach a certain speed and to optimize the acceleration and braking system of vehicles. 4. Sports. Acceleration is a critical component of many sports such as track and field, football, and basketball. Athletes must be able to accelerate quickly to gain an advantage over their opponents, and trainers use acceleration data to monitor and improve athletic performance. 5. Medical science. Acceleration is used in medical science to study the impact of forces on the human body during physical activities such as sports, accidents, falls, and other trauma. It can also be used to assess the physical performance of individuals with health conditions such as Parkinson's disease or stroke. Astronomy. Acceleration is used in astronomy to study the motion of celestial objects and the forces that act upon them, such as gravitational forces and the effects of dark matter. It helps astronomers to understand the formation and evolution of the universe. What is velocity time graph? A velocity time graph, also known as a speed time graph, is a graphical representation of an object's velocity or speed over time. On the horizontal axis, time is plotted, while on the vertical axis, velocity or speed is plotted. The shape of the graph can reveal various characteristics of an object's motion, such as its direction, acceleration, and deceleration. Here are some important features of a velocity time graph. 1. Slope. The slope of the graph represents the object's acceleration. A steeper slope indicates a greater acceleration, while a flat slope indicates no acceleration. 2. Horizontal line. A horizontal line on the graph indicates that the object is moving at a constant speed or velocity. 3. Positive slope. A positive slope on the graph indicates that the object is moving in a positive direction or towards the positive end of the axis. 4. Negative slope. A negative slope on the graph indicates that the object is moving in a negative direction or toward the negative end of the axis. 5. The curvature. The curvature of the graph can reveal information about the object's acceleration. If the graph is curved, the object is experiencing changing acceleration. 6. Area under the curve. The area under the curve of the graph represents the distance traveled by the object during specified time interval. The following information can be obtained from the graph: acceleration, retardation, distance, and average speed. Here is a picture depicting a velocity time graph. What are the differences between velocity and acceleration? Number 1. Velocity is the rate of change of displacement, while acceleration is the rate of change of velocity. 2. Velocity is a vector quantity because it consists of both magnitude and direction. Acceleration is also a vector quantity as it is just the rate of change of velocity. As velocity is a vector quantity, obviously, acceleration is also. 3. Velocity may be positive or negative or zero. But acceleration may be positive or negative. It cannot be zero as it is defined as the change in velocity or speed. This explains that there should be some motion for acceleration. 4. The SI unit of velocity is meter per second, while the SI unit for acceleration is meter per second square. 5. The formula for velocity is displacement over time, but the formula for acceleration is velocity over time. We've come to the end of the first part of rectilinear acceleration. Try out the following questions to assess yourself. Number 1. What is acceleration? 2. differentiate between uniform and non-uniform acceleration. Thank you for learning about rectilinear acceleration with me. In our next lesson, we'll solve some questions involving acceleration. Bye!